Good day, everyone. My name is Argit, presenting on behalf of our team from Universitas Pendidikan Indonesia and Sibora Institute of Technology. So, our research is mainly talked about sustainable energy, with the title of our work is optimizing vehicle access wind turbine performance with IoT-enabled remote monitoring. So, on this agenda, I will summarize the problems, our system design, key result, and future deployments. So, for the introductions, in the future, global energy demand is expected to rise significantly by 2050, creating an urgent need for efficient, sustainable generations. Vertical axis wind turbines are promising for urban areas or rural areas where but they requires a better monitoring to maximize performance, and that is why our research goal is to design a scalable IoT monitoring systems that deliver low latency, reliable, real-time data for operational optimizations. On the previous studies, around 2020 until 2022, they are commonly used Arduinos with XB, Bluetooth, Wi-Fi, or GSM model. These implementations are suffer from short range, unstable links, and high latencies. It could be sometimes minutes or seconds, but still, it's limiting real-time control and scalable deployments. So that is why it's motivating us to choose ESP32s, QTTs, and modern cloud database, Firebase, to close those communication gaps. And based on our motivations, our approach is experimental engineering approach where we divide by two approach. The first one, we are designing the hardwares, and then after that, the second one, we are designing the software systems. And this is on this text, we could see this is the final how we are integrating between hardwares and the softwares. Okay, so as, as I say, the first one is how we are designing our software. So the first steps, we are designing the hardwares where the data are going to collect by these three sensors from the wind turbines, and it's going to proceed by our ESP32s, and after that it's going to send it to the database, and our softwares are going to get it the data and showing it on our interface. And here are the details for how we are connecting the sensors into our ESP32. Okay, so the next ones are how we are designing our software systems. It starts from the Arduino IDE to set up our ESP32, how they are going to sense the data from the sensors, and after that it's going to send it to entities, and it's going to send it to HiveMQ as blockers, and after proceed there, it's going to send it to Firebase database to store all the data to scalable systems. And after that, how we build the Android applications. We are using the Android Studios as an IDE, and we are using based on Kotlin programming language. And here are the interface from our softwares. So the next ones are how our IoT architecture works, starting from the perception layers where the sensors are going to sense the data from the wind turbines, and all the data are going to proceed by network layer to send it to send the data, all of the data that are get from the sensors to the HiveMQ as the brokers to proceed the data and stores the data into Firebase database. And then after that, the after proceed the data, it's going to send it to application layer. The application layer that we are implement are Android applications. So based on these architectures, IoT architecture will enable futures local processing, such as like edge deployment without reworking the whole systems or these whole layers. Okay, so the next one. Here are our result. This is how we collect the data. As we can see, there is the wind turbine data where this is the speed of the winds is all around 2 to 8 meter per seconds, and then also there is a voltage sensors. They are sensing the data around 21 to 23.5 volts, and then our wind turbines are produce and current around 1 to 3 amperes. And here are the 70.5 is the maximum power that we can get if the wine is reach the top of the speed. It's around 8 meter per second. So based on the result of our data observations, we could see on the graph the data is really the gaps is not too far. So uh, based on that is we are achieving a low latency and stable data transmissions, and our Android applications are providing a user-friendly interface, and it's also real-time visualizations, and also it's enable synchronized to multi-device. So everyone who has same application will see the same data. So our conclusions based on our research is IoT integration significantly improves vertical access one-to-one monitoring efficiency by enabling continuous remote data acquisitions. And our hardware design, such as like ESP32 MQTT Firebase design is reliable, low cost, and scalable for distributing system maybe in the future deployments, and the architectures that we build. Uh, we hope it's going to be a modular system, so people could be uh, as could people could be redesigning the systems could be better. And the next steps from our works. So maybe we are going to integrating it with a predictive analytics and automated control to reduce downtime and also for improving the energy sustainable energy systems. So maybe that's it. Here are our reference that we are using, but these are just a few. For the detail is on the papers. So, thank you for listening. I welcome questions and collaboration opportunities. Maybe that's all for me. Thank you very much and good day, everyone.